Okay, and on the second question, it is based on two mutually perpendicular direction derivation. We need to use those equations. So stress acting in mutually perpendicular direction, the second derivation. There is a tensile stress at a point across mutually perpendicular planes. So that is major plane, and that is major stress is acting and minor stress is acting on the plane of 120 and 60 Newton per mm square. We need to find the normal, tangential, and resultant stresses. The plane is inclined at 30 degrees to the minor stress. 30 degrees to the minor stress. Okay, I think you have taken this question, so I'll start. So what is given? Tensile stress at a point across two mutually perpendicular planes are given. So this is a plane. So in this plane, so they are given the two stresses. The higher stress will be the major stress. The major stress will be along x-axis. So note that as sigma 1, and the minor stress will be in the y-axis, that is sigma 2. Sigma 2. So this will be the minor stress axis, and x-axis will be the major stress axis. X-axis will be major stress axis. Okay. So what they are given? What is the major stress? How much? Sigma 1 is how much? Sigma 1 is the stress which is highest is the major stress, that is sigma 1, and the stress which is least, that will be sigma 2. So sigma 1, so this is 120 megapascal or 120 Newton per mm square. Sigma 2 is how much? Sigma 2 is 60. So this is 60 Newton per mm square. If the stress is tensile, we take that as positive. If it is compressive, we take that value as negative. Okay. So this will be acting in both the directions. So this is a major stress. This is minor stress axis. Whereas this one is major stress axis. Major stress axis, or this is minor stress axis, or we call it as major plane. This is major stress axis, or we call it as a minor plane. Okay. So and what one more data is given, there is a plane which is inclined at an angle of, there is a plane which is inclined at an angle of 30 degree with respect to a minor stress. So this will be the minor stress. So we have a plane which is inclined at an angle of 30 degrees, 30 degrees to minor stress, minor stress. So as I told in the last problem, if it is inclined with respect to this vertical, the theta is directly taken as whatever it is there. That is 30 degree only. If it is inclined with respect to x-axis, that is a major stress axis, the theta will be 90 minus the given angle. Okay. So here you need to find what? Here they are given sigma 1, sigma 2, sigma 1 is given, sigma 1 is 120 Newton per meter square or megapascal, sigma 2 is 60 Newton per meter square or megapascal, both are same, and theta is given, theta is direct, since it is 30 degrees, since it is inclined to a vertical, that is major stress axis or minor stress axis or major plane, it is directly the given angle. So you need to find a normal stress sigma n, you need to find sigma t, and you need to find resultant sigma r. Sigma r. Okay. So you have derived the second equation, that is second derivation, that is perpendicular to two plane. Here the stress is only two stress is acting, one in the x direction, another in the y direction. So can anyone tell the equation for normal stress? Normal stress is given by normal stress. So what we derived, sigma n is equal to, for biaxial stresses, second derivation, sigma n is given by what? Sigma 1 plus 2 by 2 plus sigma 1 minus sigma 2 into what? Sin theta or cos theta? Sigma 1 minus sigma 2 into anyone? It is cos 2 theta. Okay. So you have all the values. So it is direct. You should remember the equations. And with respect to given problem, you should apply those equations. So this is normal stress. So you calculate the normal stress. So all the values are known. So only you should be careful while taking theta as it with respect to first problem and this problem. Theta, since it is with respect to a minor stress, it is direct. Otherwise, if it is with respect to a major stress, it should be 90 minus given angle. Theta. So it is a direct substitution. So next tangential stress. Next you find out tangential stress. Tangential stress. So you find out this value, how much it is. So it is in Newton per mm square. Tangential stress sigma t, it is given by, sigma t is given by, what is the equation? Sigma t is given by sigma 1 minus 2 by 2 into sine 2 theta into sine 2 theta. It is a direct equation which is derived. So you find out this. So this will be Newton per mm square. So the last one, resultant stress. Resultant stress is given by sigma r. Sigma r is equal to root of sigma l square plus sigma t square. So you should remember the resultant stress equation. It is nothing but root of the normal stress plus tangential stress square. Okay, if anyone has done, you say the answer, I'll write. So what is normal stress? How much? Okay, whatever we are done, we'll complete today's class and all the derivation, what it has been completed, it has to be uploaded by today, 6 o'clock. I will submit the assignment section that has to be uploaded in the assignment. All three derivations with these four problems, what we saw. Okay. So you can do those. You have all the values. So use your calculators. So find the stresses. So next, we'll solve a problem on third derivation what we did with biaxial stress along with shear, along with shear. Okay, note down this third question. So here at a point within a body is subjected to two mutually perpendicular stresses, that is tensile, both are tensile. So the major stress is 80, a minor stress is 40. Each of the above stress is have accompanied with shear stress. Along with the axial two stresses, there is a shear stress of 60 Newton per mm square. So it is a third case what we derived. So you need to find the normal shear and resultant stress on an oblique plane which is inclined at 45 degrees, with the axis of minor tensile stress. The axis of minor tensile stress. So diagram which is similar. I think you have completed, taken the problem. Here they are given a plane which is subjected to major stress sigma 1, that is two component, two perpendicular stresses. Sigma 1 is a major stress, sigma 2 is a minor stress, and these two stresses are accompanied with shear stress tau. Shear stress tau. The major stress is highest, so this will be equal to 80 Newton per mm square. This is given in the problem, right? Next, a minor stress, it is 80 tensile. It is tensile, so it is taken in the outward direction. And the minor stress, it is sigma to 40 Newton per. So this is equal to 40 Newton per mm square. And it is accompanied with a shear stress of, so this is shear stress are same, it is 60 Newton per mm square. And you need to find the normal, tangential, and resultant stresses along the inclined plane, which is inclined at 45 degrees with the axis of minor tensile stress. So this is the axis of major stress. So this will be the axis of a minor stress. So this is inclined at 45 degrees. So which is inclined at 45. This angle of the plane is 45 degrees. So you need to find the stress along this inclined plane. That is normal, tangential, and resultant stresses. So these direct values are directly which are given. You need to use the derivation. That is what we have done. The equation for normal stress. So directly they are given theta is 45. Since it is inclined to the minor stress, if it is 45, whatever which is inclined, the angle will remain 45. So theta. If it is inclined to the major stress also, 90 minus 45, it will be 45 itself. So now it is inclined with respect to a minor stress, the theta will be the given angle itself. What is the normal stress? Normal stress. Normal stress. So you can name this plane as something like PQ, normal stress on plane PQ is given by what? Sigma n is equal to normal stress. It is given by sigma n. Sigma n is equal to sigma 1 plus sigma 2 by sigma 1 plus sigma 2 by 2 plus sigma 1 minus sigma 2 by 2. Sorry, sigma 1 minus sigma 2 by 2 into sine 2 theta into a sine 2 theta plus tau into, sorry, this is into cos 2 theta plus tau into sine 2 theta. So you need to note down, otherwise else you cannot remember the equation. You note down all the equations with respect to the particular module 1, module 2, separate sheets, so that it will be easy to go through with and to remember the equations. So sigma n is given by, so this is the equation what we derived in the last class. So sigma 1 plus 2 by 2 plus sigma 1 minus 2 by 2 into cos 2 theta plus tau into sine 2 theta. So all the values are directly, it is given in the problem. Only you need to substitute, find out the normal stress. So in few problems, instead of giving the force, they will give the load. Instead of giving the stress, they will give the force or load. So in that case, they will give the cross-section details. You should find the area first. So you know stress is equal to force by area. You should find the stress first, then go and substitute in the equation. So this is sigma n. So similarly, you find a tangential stress. Tangential stress is given by tangential stress. It is given by sigma t. Tangential or shear stress, both are same. Tangential or shear stress is given by sigma 1 minus 2 by sigma 1 minus 2 by sigma 1 minus sigma 2 sine 2 theta. Reverse side. Sorry for this. So it is cos and sine and cos. Sine 2 theta into cos 2 theta. So if it is asked to find, place it on the principal plane, you should place the normal stress, tangential stress, right? If resultant stress also, it is asked, you need to find the inclination tan phi. Can follow with the derivation. Anybody has calculated the normal stress? How much? So since it is all the values are directly given, it is a direct substitution. So use your calculators. Sigma n is how much?
120.
Yeah, this 120 you will get 120 Newton per mm square or megapascal, both are same. Sigma T 90 20 20 20 right 20
Yes, sir.
Newton per mm square. Similarly, you find a resultant stress. It is a direct equation. Resultant stress sigma r. It is a general equation. It is similar. That is root r sigma n square plus t square. T square. Sigma t square. Calculate how much it comes. So it is, these are direct problems with respect to the general equations. In next few problems, they will ask you to find the maximum stresses. Then as I told in the last class, you should remember the normal stress equation and tangential stress along with their maximum and minimum stress equations in the last derivation. So it is nearly how much? Sigma r you will get? 1?
121.6.
21.65.
1 to 1.65 Newton per mm square or megapascal, both are same. Okay. So problems are simple. The subject is easier. Only thing there are many different types of problems. So out of we have solved 3 derivations, and one of the derivation has to be done by you, as I told. When the plane is subjected to only shear, that is, for example, here only, if this is the plane PQ, it is only subjected to shear. So that derivation has to be done by you. If it is only subjected to, it is only a shear stress is acting on the plane. Only tau is acting. That has to be done by you. So the resolution of the force in the same derivation what we have done in the last class. So you remove all the sigma 1, sigma 2 forces. You will be remaining with only tau. So you resolve that force. So it is already resolved. You can use that same resolved forces what we have resolved, and you can derive the equation. You can derive the equation for shear stress along the plane. That has to be done by you. That is not done. The fourth, that is actually the third derivation. After that, the fourth derivation has been done. So next, note on the last problem. Fourth one. So this is with respect to maximum stress, I think. Here they are given a direct stress 120 and 90. This one is tensile. 120 Newton per mm square is tensile. That is major stress is tensile. And a minor stress is compressive. 90 Newton per mm square is compressive. On a perpendicular plane at a certain point in a body, they are also having accompanied with shear stress on the plane. That is a mutually perpendicular stress with shear stress. It is the third case what we derived. The greatest principal stress at the point due to this is, so they are given the greatest principal stress at the point. Greatest principal stress, that is a maximum principal stress is given. Maximum principal stress at the point is 150 Newton per mm square. So find the magnitude of shearing stress. Tau is not given. You should find tau first. Then maximum shear stress. Magnitude of the shear stress and maximum shear stress. Sigma T maximum also you should find. So I think you have noted the problem. So you have noted down that you should, before starting, you should see the type of stress. If it is tensile, it will be positive. If it is compressive, it will be in the reverse direction, it will be negative. Okay. So here, the same diagram. We have a major stress that is tensile, that is in the x direction. It is sigma 1. And the minor stress, it is compressive. So I'm reversing the direction of the arrow mark. So it is compressive. Sigma 2 is compressive. So sigma 2 is how much? Sigma 1 is how much? Sigma 1 is the major stress is highest, that will be 120 megapascal, 120 Newton per mm square. Sigma 2 is compressive. Since it is compressive, it will be minus 90. Minus 90, right? 90 Newton per mm square. So they are not given the shear. Shear, it is also acted with a shear stress. The plane is also acted with shear stress tau. You need to find this tau, and you should find the maximum. You should find tau and sigma maximum. These two you should find. So in the derivation, what we have find the maximum stress equation, and one more data is given. So what is that? The last sentence. The greatest principal stress at the point due to these stress is given. The greatest principal stress, that is sigma n or sigma 1. We have derived as sigma 1 maximum. It is given as 150. Consider problem 150 Newton per mm square. The greatest principal stress or sigma n maximum or sigma 1 maximum, both was. It is 150 Newton per mm square is given. So you use these given values and use that respective equation. So by substituting here in the normal stress, general normal stress equation, I cannot find the tau. Since theta is not given, so I cannot find tau. So there is two unknowns. So I cannot use this equation. So I can use the normal stress also value is not there. So instead they are given the maximum normal stress is given. So I can use the maximum normal stress equation. The maximum normal stress equation, it is given by sigma 1 this term. Sigma n is in terms of sigma 1 maximum. It is given by sigma 1 plus sigma 2 by 2 plus root of sigma 1 minus sigma by 2, sigma 1 minus sigma 2 by whole square plus tau square. This is the maximum stress equation, maximum normal stress equation. So this is what we derived. Maximum and minimum. Minimum is instead of plus you will get minus here. Instead of plus you will get minus. So substitute there and find out this value is given and this will be the unknown. Tau is the unknown. You should find tau. So you just cross square or you just substitute the values here first. This is some value. So let me rub this. So you just reduce the equation. It is some value, it is there, it is 150. 150 is equal to sigma 1 plus sigma 2. It is 120 minus 90. It will be 30 by 2 plus root of this term. Plus root of this term. Just take this to other side. 150 minus 30 by 2. You will be remaining with some number here that is equal to this root. You square both sides. Square both sides so that this roots get cancelled. You will be remaining with only tau. Will be remaining only with tau. So then find out tau, how much? Shear stress. Note down all the equation, otherwise you cannot remember the equation. Since wherever the new equation comes, kindly note down those equations. You square both sides, the root gets cancelled, can find tau. So here you should find a shear stress on a plane so what is tau?
106.066.
Tau is 8, not 6. Then ಬೇರೆ ಇದೆಯಲ್ಲ. So here you will get 150 minus 30 by 2 under 15. So this quantity will be 135. So that is sigma 1 minus sigma 2 by 2, that will be added. Illi sigma 1 minus sigma 2 ಇದೆ ನೋಡು.
Sir,
So here
30.
it will be minus of minus, it becomes plus. ಎಷ್ಟು ಬಂತಪ್ಪ?
30.
84 ಅನ್ನೋದು ನೋಡು.
84.852.
That is right. 84.852 unit is, don't forget to write the unit. If you miss the unit, you don't get any marks. Newton per mm square. So this is a shear stress at a plane. Then you need to find a maximum shear stress at the given point. So the maximum shear stress at given point, maximum shear stress at given point, it is given by sigma t maximum. The last equation what we did at the last, so what is that? Sigma t maximum is given by half of sigma t maximum, sigma t max equal to half of root of sigma 1 minus 2 whole square minus sigma 1 minus 2 or sigma 2 minus 1, sigma 1 minus 2 whole square plus 4 tau square. So angle of inclination is not been given in any of this problem what we solved. So that will do it in next problems. So maximum shear stress is given by the equation. Or it is nothing but the same equation or in this form. So if you leave out this first term in the maximum normal stress, this second term is nothing but this equation. This second term is nothing but this equation, or you directly you substitute this quantity. This is also a maximum shear stress. This is nothing but this is equivalent to this quantity. So here only half is taken outside. 1 by 2 is taken outside. So 1 by 2 taken outside. So this becomes 4 tau square. So either if you remember one equation, the second term is the maximum shear equation. In that sense, you should remember the equations. So either you can take this itself, the maximum, sigma t maximum is equal to this quantity, this second quantity. Both are same. This quantity is also same and this is also same. So you'll minus a plus here. Plus, sorry. So this is plus. This quantity is plus there. It is a direct substitution. Or else, if some of the values is given, so any of one of the values will be missing, you should find the missing values. The direct substitution, it is minus of minus here, it becomes plus. So how much? Sigma t is
34.99.
how much?
134.9.
134.
Yes.
Okay. 134 it is, right? So it is nearly 134.59 megapascal or Newton per mm square. So inclination of the plane equation is not used here. So we may use that in next problems. Tan phi equation we are not used. Either you can use that in any of the problem. The last previous problem you can use the inclination of the plane also can be found. So along with the three derivation, that one shear stress derivation, and these four problems, problem 1, 2, 3, 4, has to be submitted by today. Post assignment. Okay. The internals will be in the next week.